Hello, today I'm going to demonstrate some gas properties that go along with the simulation that you'll be looking at shortly online. So follow along with me for the various numbers as we go through the simulation. So in number one, before we even get to the PhET, it's called, you've seen these PhETs before, I'm going to take a soccer ball and I'm going to take this relatively flat soccer ball, which doesn't look very good, and I'm going to put some air into it. Now, one of the things we would say, hopefully you're saying, well, that soccer ball, the pressure is too low in the soccer ball. And that's what we're going to find out. As I put the pin in, one of the things we're going to keep constant is the volume of the ball. So it's going to stay relatively constant. It might expand a little bit, but in general it's going to stay constant. And the other thing that's going to stay constant in this case is the temperature of the air in the ball, the temperature in the air around us. So we can see how flat that ball is. And as I pump, oh, that doesn't help. As I pump air into the ball, assuming I can do that without, there we go. There. As we pump air into the ball, and many of you have seen this before, so this probably is something that is not surprising to you, the soccer ball is getting firmer and firmer, which means the pressure inside is getting higher and higher. And we're going to think about this in terms of the collisions of the gas molecules inside the soccer ball with the soccer ball, with the walls of the soccer ball itself. And having more gas molecules gives us more collisions, and what that does to the pressure. All right, so that's for number one. Let me release the pressure in there. I want it to be down in pressure, so the next time we have this, we have the soccer ball at low pressure. Number two, I've got some boiling water over here, and I've got a device that measures pressure. And this bulb right here is a amount of gas that's going to be affected by the pressure. Right now I have the valve open, so the pressure inside and out is the same. And if I close the valve, now I've sealed off the ball, and we can read the pressure off here, and it should read about 14.7 pounds per square inch, which is the English unit for pressure, pounds per square inch. As we're going to find out, a pressure, as it says at the top of the sheet, pressure is a force, which is pounds, divided by an area, square inches, so pounds per square inch is a pressure. We'll talk about other kinds of pressure measurements in the coming lessons. So as I put this into the hot water, what's staying constant in here is the amount of the gas and the volume. So the volume isn't changing. That's the idea of having this rigid bulb. But now you can see that the pressure is going up. The pressure has gone up all the way up to about 18 PSI, 18 pounds per square inch, or that's a good 20% higher than it was before. About 15 PSI before, and 20% of that is 3, so we added about 3 PSI to our pressure. Now, one thing I can do is I can release the pressure here, and you hear that hiss, and now the pressure inside and out should be equal, so when I close it up and I remove this from the hot water, the pressure should go down as the ball cools off. Let me give some cold water to help that. And the cold water will bring the pressure down even more. And so now the pressure, when it was 100 degrees Celsius, it was at 18 PSI. Now that we're back down to room temperature, it's at room temperature, it's at about 11.5, 11.6 PSI. So a big reduction in the pressure. And again, if I release the valve, you hear the pressure equalizing. And that's one of the things we're going to be thinking about in this unit, is that everything else being equal, the pressure always is going to try to equalize. In number three, I'm going to take this syringe, and we're going to be using syringes like this frequently. I'm going to pull off, in this lesson anyway, in this unit, pull out the syringe, and I pulled air into it. That was the idea behind taking the cap off. But now when I put the cap on, I've sealed up the syringe. So now what we're going to keep constant is the amount of gas in the syringe and the temperature around us. If I put the syringe on the desk and I push down, the volume is decreasing and I have to put pressure on this to have happen. As I'm pushing down, it's getting harder and harder for me to push down because the pressure inside the syringe is matching the pressure outside, which is me plus the atmospheric pressure pushing down. So the gas particles are getting closer together, and getting closer together, that means they have less room to hit the walls of the container, and so the pressure does go up. Flip over to the next page. In number 4, we're going to take a balloon. Now this balloon is open, so right now the pressure inside the balloon and the pressure outside the balloon is the same. What we're going to keep constant in this case is the temperature. The air temperature is going to stay the same, and my breath is not going to make that big a difference. And we're also going to keep the pressure the same because, as I said, pressure does try to equalize. So as I put air into the balloon is going to have to adjust so that the pressure inside the balloon and the pressure outside the balloon remain equal. So pressure inside the balloon and the pressure outside the balloon are equal, of course notwithstanding the fact that the balloon is actually holding some of the air in. But the pressure inside and outside the balloon are staying relatively equal, which means the volume had to expand to accommodate more forceful or more molecules hitting the container wall. And so it needed more volume, it needed more area in order to keep the pressure the same. For number 5, you are going to watch a video which I will have posted along with the write-up for the PhET. And in number 6, you're going to think about what should happen based on what you've seen already. Finally, in number 7, I'm going to take the syringe, I'm going to push all the air out of it, and I'm going to cap it. And now I'm going to try to pull the plunger out. And as I pull the plunger out, it becomes harder and harder to pull the plunger out. Actually, it's not becoming harder and harder. It's just hard the whole time. So what you want to think about with this, it's becoming hard because there's pressure someplace and there's not pressure someplace else. Think about what is inside the syringe. What's inside the syringe now? What's inside the syringe when I pull this out? What's pushing out from the inside of the syringe? What's pushing in from the outside of the syringe? Why is it making it so that when I let go, the plunger goes all the way in? All right, please go to the PhET now and follow the directions and have a little fun playing around with things. You can try to blow the lid off, that's a little bit of fun too, but make sure that you do pay attention to the questions that are being asked and how you can make the simulation look like our setup that we had here.